Welcome to Physics Prep. This is a question from TATA-GS 2019, and in the question, we are told that a certain particle starts here with a velocity of u and then drops to the floor. After dropping, it bounces off and goes up to a certain height, comes back down and then bounces off again. But at each bounce, it loses a certain amount of its kinetic energy, and therefore the velocity after every bounce is lesser. Here is given in terms of the coefficient of restitution, that is E here. The coefficient of restitution that is given as E is equals to the final velocity, that is velocity after the bounce divided by the velocity before the bounce. What we are told to find is the distance that it travels, let's call that x total, before it starts to slide on the ground. To get that total distance, what we need to do is first get the distance between each of these drops. And to get the distance covered in each drop, we need to know the velocity that it starts with here. But from here, we already know that the velocity here, that is, would be u times e. The velocity here would be u times e. But of course, there is only one velocity in this end and the other velocity at this end, which are linearly independent. So, resolving the initial u into two components, we can have a component that goes this way, or the x component, and then a component that goes downwards, which we can say as the y component. And from the alternate angles, this is theta, and since this is u, the upper part is u cosine of theta, the lower part is u sine theta. Now what we need to find first is x1. We can find x by using the relation u in the x direction multiplied with time plus half of at squared. Our problem here is that we don't really know t. So what we do is we use another relation, v equals u plus at, where v is the final velocity, u the initial velocity, and a the acceleration and t is the time. This we are talking in the y direction so that we can find time from here. Now if we look at the peak here, the velocity in the y direction is 0. So what we can do here is put 0 for vy, we get minus uy equals minus z times t, as z works in the opposite direction, so the time is equals to uy divided by c. We can put that up here to get half of x, because of course we are only taking up to the peak, the time up to the peak. Half of x is ux multiplied with t. This part is actually 0 because there is no acceleration, as there is no force in the x direction. So this gives us x equals to 2 times ux uy divided by z. Another thing to note here is that the ux here is actually a constant, because there is no forces in the x direction, the velocity in the x direction doesn't change. However, as we have mentioned earlier, uy keeps on changing. After the first bounce, it was uy times e. After the second bounce, it was uy times e squared. After the third bounce, uy times e cube, and so on. Which means our x total should be equals to 2 times ux divided by z multiplied with uy times e plus uy times e squared plus uy times e cubed, so on and so forth. Now what we can do here is xt equals 2 times ux, and we can even pull out uy divide by z, and then we have got e plus e squared plus e cubed plus so on and so forth. Now these terms make up a geometric series with the first term, that is a of the geometric series, as e. This is our first term, and the common ratio would be the ratio of two consecutive terms. I am taking the first and second term to get e. Now the sum of n terms where n tends to infinity for a geometric series is equals to a divided by 1 minus r. In our case, this is simply e divided by 1 minus e. To get our x total here, which is equals to 2 times ux is u cosine of theta, uy is u sine of theta, divided by z multiplied with e divided by 1 minus e. So this is equals to u squared by z, and we have got 2 cos theta sin theta, which gives us sine of 2 theta, and then this is multiplied with e divided by 1 minus e. This is our final solution.